Alright, so this is going to be geometry 6465, rectangles, rhombuses, and squares. Okay, so a rhombus, square, rectangles. First to note that a rhombus, square, and a rectangles are all parallelograms. They're all special cases of parallelograms. Rhombuses, squares, rectangles are all special cases of parallelograms. And the first one is the rhombus. And it says that a rhombus is a parallelogram with four congruent sides. A rhombus is a parallelogram with four congruent sides. So if I had a parallelogram, and I know that all four sides are congruent, then I have a rhombus. Alright, so all the stuff we talked about parallelograms in the past still apply. Angles are supplementary, consecutive angles are supplementary, the diagonals bisect each other, opposite sides are congruent, opposite sides are parallel. All of that is still true. But in the case of a rhombus, the opposite sides that are parallel are all the same length. So a parallelogram where all sides are parallel. A parallelogram where all sides are parallel. And we have a rectangle. And again, a rectangle is a parallelogram as well. But the difference between a rectangle and a rhombus is that opposite sides are parallel, and congruent. So this is congruent to that, that's congruent to that. But what makes a rectangle different from a rhombus is that we have 90-degree angles. A rectangle has 90-degree angles. And again, remember, this guy is parallel to that guy. This guy is parallel to that guy. And that all applies here too. Parallel, 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 parallel. So a rectangle is a parallelogram with four right angles. Right, and then we have a square. And a square is what happens when a rectangle and a rhombus, the rhombus saw the rectangle, thought she was looking good, and shot his shot. And they got married and had a baby. And they combined both the characteristics of a rectangle and rhombus and put it together. And we say that a square is a rhombus that has four, or all sides are congruent, and four right angles. So it puts those two characteristics together. All sides are congruent, and there's four right angles. We just merge the two. We add the two conditions together. So a square is a parallelogram with four congruent sides and four right angles. Okay, four congruent sides, four right angles. All right, rhombus, parallelogram with all four sides congruent. Rectangle, parallelograms with uh, four right angles. And a square is a parallelogram with four congruent sides and four right angles. They get together, have a baby. Alright, which leads to a whole bunch of theorems. This thing here says parallelogram EFGH. Is it a rhombus, square, or rectangle? So we have this parallelogram EFG and H. This problem is done really, really well. It makes you think. So our EFGH, right? And we're told that it's a parallelogram. We know that it's a parallelogram at least. But we need to find out what type of parallelogram it is. So, we know that the definition of a parallelogram, or one of the theorems, I think it was 6.5. If it's a parallelogram, then opposite sides are congruent. So this guy and this guy, if opposite sides are congruent, the opposite side of this side of the parallelogram is this. So if this is that length, then that guy has to be congruent. If this is that length, then that guy has to be congruent. So now I know that all four sides are congruent. And a parallelogram where all four sides are congruent is a rhombus. So this is a rhombus. Well done question. Alright. If a parallelogram is a rhombus, then its diagonals are perpendicular. Theorem 6.13. If a parallelogram is a rhombus, then its diagonals are perpendicular. If a parallelogram is a rhombus, then its diagonals are perpendicular. A, B. Alright, I know it's a rhombus. And if it's a rhombus, then when I have its diagonals, will be perpendicular. Right. If it's a rhombus, then its diagonals are perpendicular. Right. So if parallelogram ABCD is a rhombus, then AC is perpendicular to BD. Then we have theorem 6.14 that says if a parallelogram is a rhombus, then the diagonals bisect each other. Oh, diagonals bisect a pair of opposite angles. Alright, so what does that mean? Alright. It means if I have a rhombus and that means that I know that it's a parallelogram with all four sides the same. I have my diagonals. I know that the diagonals are perpendicular now. I also know, remember that opposite sides of a parallelogram are congruent. So if opposite sides of a opposite angles of a parallelogram are congruent, what this theorem says is that not only are they congruent, but they're angle bisectors. So you have 1, 2, and 3, 4. Here we have 5, 6, and then 7 and 8. If it is a rhombus, then angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. Actually, let's do it this way. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Also, angle 5 is congruent to angle 6, angle 7 is congruent to angle 8. These guys are cut in half, cut in half, cut in half, cut in half, so these guys must be congruent to each other. Alright, if a parallelogram is a rhombus, oh, this is set up a little different. That's fine. 1 is congruent to 2, 4 and 5 and 6 are congruent, and these guys will be congruent to each other. Alright. Here I'm told it's a rhombus. Here I'm told it's a rhombus. And then they want me to know what the angles are in the measured angles. Dang. I was hoping. So rhombus, all 4 sides are the same. Sort of. I have this diagonal. I have a 1 and a 2. I have a 3 and a 4. First off, I know a rhombus is a parallelogram, so I know that these two guys, so this is P, Q, R, S. Since a rhombus is a parallelogram, I know that angle P is congruent to angle R. Angle P is congruent to angle R. They're the same angle. I also know that angle Q is 104. And I know that 104 I'll say this. I know that angle Q plus angle R is supplementary. They equal to 180 because they're consecutive angles. I also know that angle Q and angle P are supplementary as well because they're consecutive angles and they add up to 180. So P and R add up to 180. Q and R add up to 180. Q and P add up to 180. Yay. I also know that since this is a rhombus, that P is equal to angle 1 P is equal to R, right? Or congruent to R. So that means that P is equal to R. So I can say that the measure of angle P is equal to the measure of angle 1 plus the measure of angle 2. I can also say that the measure of angle R is equal to the measure of angle 3 plus the measure of angle 4. And since P equals 1 plus 2 and R equals 1 plus 2, I can just substitute that in, and I can say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Okay? I also know that since this is a rhombus, that angle 1 is equal to angle 2. I also know that angle 3 is equal to angle 4. So they're the same. So I can say, instead of calling it 1 plus 2, I can say that 1 and 2, let's say that 1 and 2 equals x. I know that 104 and 102 is supplementary. I know that q is 104. So if q is 104, I subtract 104 from both sides. So that means that the measure of angle r and the measure of angle p both equal 180 minus 104, which is 76. So r and p equals 76. I'm going to say that 1 and 2 equals x. So I can say that x plus x equals 76. So now I can say 2x equals 76. Divide by 2, x equals 38. So x equals 38 degrees. So this is 38, this is 38. And since these two angles are the same, this also equals 38, and this also equals 38. So then ultimately I can say that the measure of angle 1 equals the measure of angle 2, which equals the measure of angle 3, which equals the measure of angle 4. And that equals 38 degrees. Alright, parallelograms that are rectangles. Alright, if a parallelogram is a rectangle, then the diagonals are congruent. If the parallelogram is a rectangle, then the diagonals are congruent. So I know it's a rectangle. This is theorem 615. And I know it's a rectangle because they're all 90 degrees. If it's a rectangle and I have my diagonals, then I know that all the diagonals, the diagonals are congruent. So I have A, B, C, D. So I know that diagonal AC is congruent to diagonal BD. Diagonal AC is congruent to diagonal BD. Okay, so that's 615. So they give us a rectangle for a question, and I call it MNLO, and they say that ln equals 4x minus 17, and mo equals 2x plus 13. So to solve, I'm going to set these bad boys equal to each other. So 4x minus 17 is equal to 2x plus 13. And I'm doing this because I know that the diagonals are congruent because they tell me that it's a rectangle. Subtract 2x from both sides. 4x minus 17 equals 13. Add 17 to both sides. 4x equals 30? 2x, I'm sorry. 2x equals 30. Divide both sides by 2. X equals 15. They're not asking for x, they want the length of the diagonals. So x equals 15. So I'm going to plug 15 into either one. I'll plug it down here. So 2 times 15 plus 13. That gives me 30 plus 13, which gives me 43. Hopefully, if I did it right, it works for this guy too. So 4 times 15 minus 17. 4 times 15 is 60. 60 minus 17 is indeed 43. So it works with both of them. So that's good. So the answer is 43. If I have a rectangle and I have diagonals and I know that these diagonals are congruent, I also know that these diagonals bisect each other. So if they're congruent and they cut each other in half, then this guy is congruent to this guy. But since these two guys are the same length, these two guys are also congruent. So when I look at the triangles that's formed from the bisection of the diagonals of a rectangle, I have isosceles triangles. Remember, isosceles triangle is a triangle where we have two congruent sides at least. So this is an isosceles triangle. So the diagonals that bisect each other form isosceles triangles within a rectangle. So that's this section, and then we're also doing 4-5, which deals with 6-5 rather, which deals with sort of the converses of rhombuses, rectangles, and squares. So we have theorem 6.16, and theorem 6.16 says that if the diagonals of a parallelogram are perpendicular, then it is a rhombus. So we're told that it's a parallelogram. We don't know that it's a rhombus yet. We're trying to deduce that. So this is the converse of the previous section. And I know that this guy is parallel to that guy, and that guy is parallel to that guy. So I know that it's a parallelogram. Then I recognize that we have these diagonals. And these diagonals are perpendicular. If I have this situation, then I know that it is a rhombus. Alright, so if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. That's worded perfectly. I don't feel the need to add to that. If the diagonals of a parallelogram are perpendicular, then the diagonals is a rhombus. Yeah. 6.17 says if the diagonals bisect each other, or one pair or one diagonal bisects an opposite pair then we have a rhombus. Alright, so I know that it's a parallelogram. We have its diagonals, or a diagonal. So we have a diagonal. And I know this guy and this guy are the same. And I know this guy and this guy are the same. This is angle 1, 2, 3, and 4. If I know this, if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, then I have a rhombus. Alright, the diagonal, one diagonal is an angle bisector of opposite angles. Right, B is opposite angle is C. C is being bisected, the angle, and B's angle is being bisected. Therefore, I have a rhombus. 617. Again, these are all converses of the previous section. 618. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. 6, 8. I have a parallelogram. And I know it's a parallelogram, so at least I know that opposite sides are parallel. And then I have my diagonals. A, B, C, D, such that AC is congruent to BD. So if AC is congruent to BD, then I have a rectangle. The diagonals are congruent. So if the diagonals are congruent, then I have a rectangle. If the diagonals are congruent, then I have a rectangle. So, up to this point, actually I'll talk about it a little later, we haven't really talked about properties of a square. And I'll get to that in a second why that's sort of not being done. It's sort of implied, and I'll get to that in a moment. Alright, do the value of y... Alright, so if this is a rectangle, then I know that the diagonals are congruent. If the diagonals are congruent, I know that the intersection forms a bisection of the diagonal, so these two guys will be congruent. So it's going to be 5y plus 3 equals 7y minus 7, 5. Subtract 5 from both sides, 3 equals 2y minus 5, add 5 to both sides, 8 equals 2y, y equals 4. And this was the value of y. Okay? I don't care about that. Okay. So you notice they haven't really talked about squares. And because a square merges both of the conditions of a rectangle and of a parallelogram, of a rectangle and a rhombus. So we just talked about a rectangle where diagonals are congruent. Well, that same thing applies in a square. Diagonals are congruent. It also merges the condition of a rhombus, which says that diagonals are perpendicular. So they're perpendicular, but then they're also all congruent to each other as well. So it merges the two together. So a square merges all the theorems together. They had a baby and they came together. Right? So all the theorems merge together. So for a rectangle, square, all sides of the bisected diagonals are congruent. So let's put all the stuff together for A, B, C, D. All right. Let's say there's an E in here. We're putting all of this together. Square merges everything. So if we merged all of these characteristics of a square together, this is what we'll have. We'll have that, let's say this is angle 1, angle 2, angle 3, angle 4, angle 5, 6, 7, and 8. Okay. They're all merged together. So that means that AC is congruent to BD. All right. We also have that AC is perpendicular to BD. We also have that angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Angle 5 is congruent to angle 6. Angle 7 is congruent to angle 8. So we've merged all the properties of a rhombus and of a rectangle, and we put them all together. Perpendicular bisectors of their diagonals, opposite angles bisected, and that the diagonals are congruent. All those are put together to make up the properties of a square. So 6, 15, 17, 18 all apply to squares. They got married, had a baby, all their properties are put together, or their DNA, within a square, and they share them all. Okay, so that's this section. I hope you have a great rest of your day.